All right, lesson 6-2 is when we get to graph these radical functions. Now we're just going to focus on two of the functions. We're going to focus on the square root function and the cube root function. So the square root parent function, remember the parent function is just the easiest function that you can graph here. So this one's just going to be f of x is equal to the square root of x. That's just your easiest function you can graph. So to graph it, let's just grab a few points on here. I'm going to choose 0. 0 is my favorite number, but the square root of 0 is 0. So that's going to graph when I go over 0, I go up 0. When you plug in a 1 for x, the square root of 1 is 1. So when x is 1, f of x or y is 1. That's going to erase. Let's do that again. Okay. The next one I'm going to choose, I don't know the square root of 2. I don't know the square root of 3. So the next x value I'm going to choose is 4 because I know that the square root of 4 is 2. That means when I plug in 4 for my x, we could be doing an xy table. Maybe that would be more helpful. So I said when I plug in 0, square root of 0 is 0. When I plug in 1, square root of 1 is 1. When I plug in 4 for my x, the square root of 4 is 2. So that's just an ordered pair right here. When I go over 4, go up 2. 1, 2, 3, 4, up 2. And let's do one more. The only other square root that I know within this graphing range is 9. So the square root of 9 is 3. So when I go over 9, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to go up 3. Now, before we connect the dots here, look at what about negative numbers here. We cannot take the square root of a negative number. Okay, if you tried to have your calculator tell you what the square root of negative 4 is, it would tell you there's a domain error. Okay, it would say I cannot do it. Last year we talked a little bit about imaginary numbers. You can't graph these imaginary numbers on a Cartesian plane. So our graph basically starts right here. 0 is the smallest x value that we can take the square root of. You cannot take a square root of a negative number. So our picture, when I connect all those dots, is going to look like this. Notice there's no arrow going the other direction. This just has what we call an end point or start point. But it has an end on one side. It keeps going forever on the other side. Okay, so this is going to be interesting for our domain and our range. Our domain right here, remember our domain are our x values. They're whatever x's that you can take the square root of. So it's easier for me to look at the picture. I know that I can't take a square root of a negative number, but when I look here, I can see my endpoint. I can see where I'm starting this picture. That's going to be your endpoint of your domain. Okay, so domain, I can get a 0, so I'm going to put it in my square brackets right there because I can take the square root of 0. Okay, so that goes in this square brackets. And then my x's, I can take the square root of 9. So all these numbers that I skipped, I can take the square root of 2. It is a value. I just don't know exactly what it is. Your calculator does, so you can take the square root of any positive number, even if it's a nice number. So this is going to keep going. See that arrow goes out to where x is infinity right there. That is my domain. All right, the range also has a start point or an end point right here. This is the lowest y I can ever get. Whenever I take the square root of a number, it's never going to give me a negative number. So when I'm looking at my y, that 0 in this case is also my beginning of my range right here. That 0 is the smallest y I could get. And this arrow, even though it's going out right here, it's slightly going up too. So it's going to keep going up to infinity really slowly, but it does go up there. All right, this end point, turning point comes in for the cube root. So on this function, it is an end point. They just want the origin right there, 0, 0. Now, when we get to shifting our function around, moving it left and right, that endpoint will move with us. It moves left and right and up and down. So we'll show you how to calculate that. But for the parent function, it's just right there at the origin at 0, 0. All right, now end behavior is a little different this time. Notice we're writing it different too. I don't write as x goes to infinity and as x goes to negative infinity because x does not go to negative infinity on this picture. So you're going to have to fill in the end behavior. here's my easy suggestion. Your domain, that's going to give you the ends of the function. Okay, so it ends at 0 on one side, so you can put 0 right there, and it ends at infinity on the other side. Okay, so whatever those two values are for your domain, those want to get filled in for your x's. Remember, domain is your x values for the end behavior. And they don't have to be in any particular order. I just went left to right, but you just need those two domains. Now, what you're going to do is you're going to look at where x is 0. And you're going to see, where's my y? What's my y doing when x is 0? Well, right there, when x is 0, y is also 0. I will also tell you that this point, or it's not a point, but it came from a point. It came from that end point right there. So one of them is just going to be like an order pair. As x goes to 0, y is at 0 as well. Okay, however, as x goes to infinity, this is where you've got to look at this arrow that is slightly going up. Okay, these numbers are getting bigger. When I take the square root of 9, it was 3. When I take the square root of 16, it'll be 4. 25, it'll be 5. So it is slightly going up, so my y values are going up to infinity right there. All right, and then this function, both of these functions are only going to be either increasing or decreasing. Okay, so on this one, notice as we always read our graphs left to right. So as we read left to right, see how my y values are going up? That means we're increasing. Okay, we're not decreasing. So you could just cross that one off for this function. Occasionally you will have them if you reflect the function over your x-axis, it will be decreasing. So don't cross them off on all of them, but on this parent function, as I'm reading it, I am increasing. Okay, and you're always going to be increasing the entire time of the function. So go ahead and just copy whatever your domain was is going to also be that interval that you're increasing. So I hope you're good at domains, because then you get the interval increasing as well. All right, we'll pause this video and do the cube root in our next video.